Hello students, in this video we'll discuss some of the algebraic properties of continuous functions. So we have a proposition which says that if f and g map E into R are continuous at a point x equals a, then so are f of x plus g of x, the sum of these functions, and f of x times g of x. So the sum of continuous functions and the product of continuous functions are continuous. So here's the proof of that fact. Let epsilon be greater than 0 and pick delta 1 and delta 2 greater than 0 such that what? Such that 0 less than x minus a less than delta 1 implies that f of x minus f of a less than epsilon over 2, and 0 less than x minus a less than delta 2 implies g of x minus g of a less than epsilon over 2. And then if we choose delta, if we suppose if delta is just the minimum of delta 1 and delta 2, then if x minus a is less than delta, x minus a less than delta, then what we have, then we'll have that f of x plus g of x minus f of a plus g of a will be less than what? By the triangle inequality, this is less than or equal to f of x minus f of a plus g of x minus g of a, and that's less than epsilon over 2 plus epsilon over 2, and that's equal to epsilon. So that shows what? That shows that the sum of two continuous functions at a point is continuous. Now the product requires just a little more work. Let's suppose for the sake of argument, suppose for simplicity, make things simple, that g of a is not equal to 0. Okay. Otherwise it becomes fairly easy to do as well. Okay, so in that case what can we do? We choose m, so choose delta 3 such that what? Such that f of x is less than or equal to a constant if we're sufficiently close to the point A. If x minus a is less than delta 3, then we'll do the following. We're going to choose delta 4 and delta 5 greater than 0 such that what? Well, we'll think about this in a second. So let's just actually, we'll come back to what we want and we'll just actually say what we need. So we have f of x times g of x minus f of a times g of a. So over here we're using the fact that continuous functions are locally bounded, right? We're going to input what? We're going to input f of x, g of x, and then we're going to subtract off an f of x, g of a, and we're going to add in an f of x, g of a, and then we have minus f of a, g of a. And we're going to triangle inequality this and say this is less than or equal to what? This is less than or equal to f of x times g of x minus g of a. And then over here, we're going to have plus g of a, and plus the absolute value of g of a times f of x minus f of a. Of course, if g of a is equal to 0, this term is going to be 0. There's even less to do, right? But I just want to be able to make sure I can divide by it in my argument, such that what? Such that if x, now I can see exactly what I want to happen. I'd like x minus a less than delta 4 to imply that g of x minus g of a is less than epsilon over 2 times m, the bound for f. And likewise, I'd like that for x minus a to be less than delta 5. If x minus a is less than delta 5, I'd like this to imply that f of x minus f of a is less than or equal to epsilon over 2 times g of a, an absolute value, and that's why I want to make this assumption that g of a is not equal to 0. If it's equal to 0, then this doesn't make sense. But that being said, if I just have this condition over here, it makes my proof look a little bit more clean. Again, the same argument will work in the case when g is equal to 0, just with a slight modification. So now, what can we say? So now, if Rx minus a less than the minimum of delta 3, delta 4, and delta 5, right? Then what? Then we can say that this is less than or equal to m times, now g of x minus g of a will be less than what over here? It'll be less than epsilon over 2m plus g of a times epsilon over 2 g of a. And by construction, all these things are going to cancel out, the m's and the g of a's, and this just gives me epsilon. So in the words of delta minus a, if x minus a is less than this value delta, the minimum of delta 3, delta 4, and delta 5, then f of x times g of x minus f of a times g of a is less than epsilon, which shows that the function f of x times g of x is continuous at a. Thank you very much.